Static forces problems involving friction on an incline. So static forces, we're looking at a particle that isn't going to be moving, so the forces will be in equilibrium. A parcel of mass 2 kilograms is placed on a rough plane inclined at an angle theta to the horizontal, where sine theta is equal to 3/5. Given that the parcel may be modelled as a particle and that the coefficient of friction is a third, find the magnitude of the force P acting along the plane, which is sufficient to prevent the particle from sliding up the plane or sliding down the plane. So, the first thing we need to do first, as we do with most Mechanics 1 problems, is we need to draw ourselves a diagram of what is happening in this question. So, we've got our incline with a theta, we've got our particle of 2 kilograms. So if it's 2 kilograms, it means its weight acting downwards is 2g. 2 times 9.8. And we've also got from the plane to the particle a normal reaction perpendicular to the plane. If it's going to be sliding up the plane, as it is in particle in question A, then the friction will be opposing motion downhill, and there's a force P acting on it to stop it sliding up the plane. Now, the other thing we're told is that theta is equal to, that sine theta is equal to 0.6. Now what I suggest you do is I suggest you find out what cos theta and what tan theta is equal to. Well, if you find out what cos theta is equal to by doing sine to the minus 1 of 0.6, then do cos of whatever that answer is, you get 0.8, and if you do the same for tan, you get 0.75. You're also told that the coefficient of friction is a third. Now, as when we're resolving forces problems, we look at two things perpendicular to each other. The easiest place for us to look here would be up and down the plane, as we've got two forces there, and then perpendicular to that, so in the direction of r. Now that means that this 2g, the weight of the particle, we need to find out what component is acting parallel to the plane and what component is acting perpendicular to the plane. So, to do that, we look at a little right angle triangle. Remember that this angle here is going to be theta. So, here is going to be the opposite. So it's going to be 0.6 times 2g. And the vertical component, or the component in line with r, is going to be the cosine, so it's going to be 2g times 0.8. Now, remember, we're looking at a rough surface here, a rough plane, so that means we're going to have to look at friction. So the first thing we need to do, before we can find out what P is, we need to find out what F is. So we need to find out what the friction max is. And remember, friction is calculated by doing friction equals coefficient of friction times by the normal reaction. So the first thing we need to find is the normal reaction. So if we look at the forces in that direction first. So acting in that direction, we've got the R, and we've got minus the 2g times 0.8, which is 1.6 g. And that's equal to 0 because there's no acceleration in that direction at all. So R is equal to 1.6 g. Remember, this has come from the fact that we used F equals ma. Now, we know the normal reaction, we can find out what the friction max is equal to. So friction max is equal to 1.6 g times by a third. Now if you pick your calculator up and do that, you'll find that it's 8/15 G. 8/15 G. Let's rewrite that for you. Okay. Now, as we're trying to find the force that is going to just prevent it from sliding up the plane, it means we're going to be talking about the friction max. Now we know what the friction max is, we can find the force in this direction up the plane, and then we can solve it to find out what the P is going to be. So now if we look at the forces up the plane in that direction, so in that direction we've got up the plane, we've got the P. Acting against it, we've got the friction that we've just calculated, so that's 8/15 G, and also mustn't forget that we've also got the component of the weight acting down the slope, because remember gravity always acts downwards, so minus the 1.2 G, and that's equal to 0. It's equal to 0 because there's no acceleration, because we're looking at the point just before it starts to slide up the hill. So we're looking at the limiting point of this particle when it's just about to start accelerating. So F equals ma, again this is from. So tidy this up and you'll get F is equal to 1.2 G plus 8/15 G, which if you get your calculator you'll find that is equal to 16.986 newtons, which is 17 newtons to two significant figures. That's part A completed. Now part B, it says sliding down the slope. Now we just need to slightly redraw our diagram here. So everything's still the same pretty much. Okay, we've still got our particle, which is 2 kilograms. We've still got our resultant. We've still got our forces acting downwards, weight acting downwards of 2G, and we've still got our components acting in each direction. So this one here was 1.6G, and this one 1.2G. Okay, but now if we're looking at about to slide down the slope, our friction is going to be acting in the opposite direction. So instead of being this way, it's going to be up that way. So we've got our friction this way, and we're going to have some kind of force stopping it from sliding down. So you've got your P up here. Now, as the weight and the normal reaction are still the same, you're still going to have the same friction max. So the friction max is still going to be 8/15 times gravity. Now we can just find the forces acting up the slope, and we should find out what the P is equal to. So if we look at forces up the slope, we're going to have the P plus the friction, which is 8/15 G, minus the component of the weight acting downwards, which is 1.2 G. Still equal to 0 because we're still looking at the point just before it starts to accelerate down the slope. Now if you work that out, so if you just rearrange this to get P on its own, you have 1.2 G minus 8/15 G, which if you calculate that out, you should find that the P is equal to 6.5 newtons. Now with these style questions, it's really important to make sure you draw a really clear diagram and to make sure you identify the components of the weight that's acting down the slope and the weight that is acting perpendicular to the slope, and then to calculate the friction max by remembering that friction max is equal to the coefficient of friction times the normal reaction.